Conceptualizing z-scores. In this problem, we are asked to explain to Judy in simple language what the standardized score tells her about her hip bone density. We were given her hip bone density at 948 grams per centimeter squared, and the mean, otherwise known as the average hip bone density of other 25-year-old women like her, at 956 grams per centimeter squared. We were also given Judy's z-score at negative 1.45. Using this to find the proportion in the front of the book, using Table A, we multiplied the proportion times 100 to get her percentile, which was 7.35. This means that only 7.35% of all 25-year-old women like Judy have a hip bone density equal or less than her. In other words, 92.65% of women her age have a hip bone density greater than hers. So even though her hip bone density is only off the mean by 8 grams per centimeter squared, she actually has quite a low hip bone density in comparison to the rest of the population. In B, we are asked to use the information provided to calculate the standard deviation of hip bone density in the reference population. So we were given her z-score, and we know her, and with this z-score we know her hip bone density and the average. So we set it up using the formula at the top of the page, putting her z-score on the left equal to her hip bone density minus the mean over the standard deviation. We multiplied over the standard deviation and subtracted the mean from her hip bone density, which was negative 8, and then we divided the negative 1.45 over, and the standard deviation was 5.52.